Hello, everyone. Tonight's workshop from the Haverford Township EAC is on the simplified approach to stormwater management for small home construction projects. So a little bit of background. Last year, the township's stormwater ordinance was updated, and there were a couple of important changes that were made. So the first is that under the new ordinance, there's a lowered threshold for regulated impervious areas that dropped from 1,000 to 500 square feet. And that threshold is now cumulative back to February 15th, 2005. So what that means is that if you have a small, home construction project or any construction project where you're proposing to add impervious area greater than 500 square feet, since February 15th, 2005, that now triggers stormwater management planning and review by the township. And for larger projects, this typically requires, detailed surveys, soil testing, and engineering design and runoff calculations. But the good news is if you're doing a smaller project on your home, if you're more of a DIY person, there's a simplified approach that is available in the ordinance, as long as your project is not proposing to add more than 2,000 square feet of impervious area. And that's what tonight's workshop is about. We're going to go through the steps and try to show you all, how that simplified approach works so you can make use of it. The simplified method is explained in Appendix B of Chapter 78 of the Haverford Township Code. And as I said, this is available to individual home construction projects. So projects on single family lots with less than 2,000 square feet of new impervious area. It's a prescriptive approach, so it kind of gives you a menu of options for capturing and treating runoff from your new impervious area. Those are usually called stormwater best management practices, or BMPs. And the calculations are already done for you. So there's no need to hire an engineer or a hydrologist or anything like that. It's all explained in the appendix. The site plan that you're required to submit using the simplified method can be just a simple hand-drawn sketch. You don't need to hire a surveyor. You don't need to get topographic maps or anything like that. And the only other requirement is that you have to sign an agreement. You have to enter into an agreement with the township that you will operate and maintain those BMPs that you're using to capture and treat stormwater from your new impervious area. So the steps under the simplified method are as follows. First, essentially, you determine the total area of your proposed impervious surface. And as long as that is below 2,000 square feet, you can use the simplified approach. If you are below the 500 square foot threshold, then you actually don't have to submit anything to the town. Just be aware that, the threshold is now cumulative, right? So if you add 100 square feet of impervious area each year, once you cross that 500 square foot threshold, you're going to trigger these requirements then. Step two is, once you've calculated your impervious area, you're going to determine which stormwater BMPs you want to use to capture and treat your stormwater and where you're going to put them. Once you've figured that out, you can then determine the amount of impervious area that's contributing stormwater to each of those BMPs. And we're going to go through this to give you an example. Then you can use the calculations that are in the appendix that are already performed to figure out the size or the dimensions of those BMPs that are going to be required. And then finally, you show all that on a simple sketch plan. You submit your plan and the worksheet and the signed O&M agreement to the town. The township engineer will review it, and once you're approved, then you're good to go. So the best management practices that are available under the simplified approach are rain barrels and cisterns. You can use rain gardens or bioretention swales. It's just another name for the same thing, essentially. Or you can use dry wells or infiltration trenches. And these are all, fairly simple BMPs that could be installed by a homeowner or a contractor. So just to step through each of these, rain barrels and cisterns are designed to capture stormwater and hold it. And then the idea is that you use that stormwater for irrigation or for other purposes before the next storm event. So you're capturing, at least that first inch of runoff where most of the stormwater pollution impacts are from, and you're kind of preventing it from going into the town stormwater system or into the road where it could cause flooding or other issues. A couple requirements if you want to use rain barrels as a BMP. They're supposed to be labeled as non-potable, right? You don't want anybody drinking this water. You have to provide an overflow point. So you can see in this picture on the top right here that at this house, they're using 3 rain barrels in series, and each one kind of has an overflow that when the barrel fills up, it pours into the next one. But you want to make sure that the ultimate overflow location, you divert that away from your foundation walls because you don't want that water getting into your basement. You need to use screens or other methods to filter out any leaves or debris from your roof from getting in here and potentially, filling up the barrels or clogging them up. They need to be closed so they don't attract mosquitoes. And you'll see when we go over the sizing spreadsheets that uh, we're assuming that they're 25% full, right? Ideally, you would empty them after each rain event, and so that the full capacity is available for the next rain event. But we know that people go on vacations and things like that, so we're assuming that they are, essentially always 25% full. The next type of stormwater BMP that's available under this approach is rain gardens. And these are just sort of, gardens that you can put into your lawn that, again, capture and hold that stormwater. And instead of releasing it out to the street or into the storm sewer, it sort of slowly filters down through the soil and infiltrates back into the groundwater. A couple requirements for rain gardens: you want to make sure to use native plants that can tolerate both dry and wet weather. That'll result in a lot less maintenance of the rain garden. You want to size and construct the rain garden so that the ponding depth is less than 1 foot of water. You don't want to have more than 1 foot of water in the garden. These as well, because they're designed to infiltrate stormwater into the ground, you want to make sure they're located away from any basement foundation walls. We would typically say at least 10 feet away from the foundation. And these also are required to have an overflow point. So in this figure here, they're using sort of a domed riser that, once it fills up to a foot, the water then flows into that riser and discharges elsewhere. You can also construct them such that, once it gets to a certain level, it just overflows over a berm into a safe sort of vegetated area where it's not going to cause any flooding issues. And the soil and planting mix in the rain garden should generally be between 1.5 to 6 feet deep. Another BMP that you can use under this approach is dry wells. And so these are underground structures that are designed to hold a specified amount of stormwater and again slowly infiltrate it, let it go back into the groundwater where it's supposed to be and not just run off out into the street. Because of that, you also want to locate these at least 10 feet away from foundation walls. And you have to provide some amount of filtration so that you're not getting, sediment into these things. What happens is if you allow dirt and sediment in there, it starts to clog up the pore spaces, and eventually the dry well will lose its ability to infiltrate the water over time. It'll get clogged up. Another thing you need to be careful about if you're going to use a dry well is to avoid soil compaction during construction. So you would typically do all of your site grading work first before you put these things in. You don't want to have heavy equipment driving over the soil and compacting it, because that will, again, it will compact the soil and it will cause the dry well not to infiltrate water the way it's designed. These should be approximately 1.5 to 4 feet deep, and they are filled with a graded sort of washed stone that's then wrapped in geotextile. So the geotextile fabric, again, prevents dirt and sediment from getting into the voids between the stones and clogging up your dry well, which will just mean that it'll stop working. They need to be installed with a monitoring well because you have to inspect these things periodically to make sure they're functioning properly. And they also need to be constructed with an overflow location, right? So once this thing fills up, any extra water needs to have a place to go in the case of like a very, very large storm. And the final BMP that's allowed under this approach is called an infiltration trench. It's very similar to a dry well but except, instead of being like a circular well, it's more of a linear feature. So this again, it captures stormwater. It's designed to hold a specified volume of stormwater, which then slowly infiltrates back into the ground. The width is generally between 3 to 8 feet, and they're approximately 2 to 6 feet deep. These again, you want to make sure that you're not letting, dirt or sediment or leaves get in here. You want to provide some kind of screen or filter to prevent that from happening because it will clog up and eventually fail if you don't have that. And again, they need to have a safe overflow location to a pervious area. You don't want to put these within 10 feet of your basement foundation walls because you may end up with water in your basement. And with the infiltration trenches and the dry wells, it's generally a good idea to do some soil infiltration testing. You can look online. There are methods to do this. There's simple ASTM bucket tests that you can use to do this. But you wouldn't want to put these, for example, you wouldn't want to install them in like a layer of clay, right? Because clay is very fine. It's not going to allow that stormwater to infiltrate back down into the ground where it belongs. And again, when you're building these things, you want to avoid the use of heavy equipment you need to protect this area when you're building it so you're not compacting the soil and limiting the infiltration. So now we can sort of step through this process and go through it together and kind of see what it looks like. So here's an example, single family lot with an existing house and an existing concrete walkway. And the homeowner would like to install a 400 square foot garage and a 540 square foot driveway. So step one of the simplified approach, we figure out, the total amount of new regulated impervious area that we want to add. In this case, that would be 940 square feet, right? So we're over the 500 square foot threshold. We've triggered the stormwater management regulations, but because we're below 2,000 square feet, we're allowed to use the simplified approach, which makes this a lot simpler and faster and easier. So step two is to determine which BMPs we're going to use to capture and treat stormwater from this new impervious area. So for example, we could use a rain barrel or cistern up here to capture the runoff from the back half of the garage, right? All that runoff will go into a gutter and then into a downspout, and we can use rain barrels or a cistern up here to collect all of that. The second BMP that would probably make sense in this situation is an infiltration trench that can capture runoff from the front half of the garage. And if we construct the driveway and we slope it the right way, then all the runoff from the driveway will also enter that infiltration trench. So these two BMPs should be able to handle all of the runoff from the new impervious area that we're proposing to install. So let's look at BMP number one, the cistern first, and we'll figure out, what size does it need to be. So this BMP one is capturing half of the runoff from the 400 square foot garage. So it needs to be big enough to handle 200 square feet of impervious area. And in Appendix B, all of these calculations are already done for us, right? So we just look at column one here, where we want to treat 200 square feet of impervious area. And using this spreadsheet, we need to have our rain barrel or our cistern. It needs to be at least 166 gallons. And again, this is assuming that it's about 25% full on average. So that could be, 3 55-gallon barrels in series, or you could buy, one larger cistern and use that instead. I would generally suggest that you want to oversize these things because it's just always a good idea to be able to hold more water than the absolute minimum, right? The other thing I should mention about these tables that are provided in the appendix is, say you're between 200 and 250 square feet of impervious area. You're not allowed to round down, right? So if we were at like 215 square feet, we would round up to 250, and then we would have to have at least 208 gallons of capacity in our rain barrels. So we figured out, the minimum size that our cistern needs to be. And so we can go ahead and put that on our sketch plan here. And I'm going to oversize mine a little bit. I went with 200 gallons. So now let's figure out how big we need to make our infiltration trench. So this infiltration trench is going to get half of the garage and the whole driveway. So that's a total of 740 square feet of impervious area that's connected to it. So in Appendix B, there's a table that's provided for infiltration trenches. And we were at 740, so we round up to 750 square feet. We can see for that amount of impervious area, we need to be able to hold 156. Our infiltration trench needs to be 156 cubic feet in volume. Okay. And these can be constructed with varying depths. Let's say that we're going to build ours 3.5 feet deep. Maybe we did, some test digging and we found a nice uncompacted layer of soil with good infiltration capacity around 3.5 feet deep. We're going to dig down that far and make that the bottom of our trench. That means that our infiltration trench has to have an area of at least 45 square feet. And again, it's never a bad idea to oversize these things. So we can go ahead and put our dimensions here on our sketch plan, right? We said 3.5 feet deep, and we're going to make it 15 feet long and 4 feet wide. So that'll give us a total area of 60 square feet. Slightly oversized, just to be safe. And there's a couple other items that we need to add to our sketch plan for it to be complete. We have to put the name of the property owner, the address, and the submittal date on here. And there are some features that if they're present on your lot or within 50 feet of your BMP, you have to show those as well. So the first thing that you want to make sure to show is if there's any streams. We are not allowed to put stormwater BMPs within 50 feet of any stream, right? And let's say we had a stream over here on this property. I would just add a simple dimension on the bottom to show, the township reviewer that these things are located, much more than 50 feet away from the stream. We're also required to show the location of any septic systems or drinking water wells. So let's say this property has a well located here. Again, I'm going to put a simple dimension here to the infiltration trench that shows that, we're about 100 feet away from that well. I'm not really concerned about the cistern because that doesn't infiltrate water, right? That water is being held in a barrel. It's not going into the ground, but we're going to add these dimensions. And at this point, our simple sketch plan is complete and it's ready to be submitted. The next thing that you have to submit to the township under the simplified approach is this worksheet. And here it's just a table where we're entering in the requirements of our BMPs, right? So we've got 2 BMPs. The first is the cistern, and that is treating 200 square feet of impervious area for BMP 1. And we've determined that for 200 square feet of impervious area, it needs to be at least 166 gallons. This is basically just showing your work, right? That you did the calculations correctly or that you followed the table correctly. Our next BMP number 2 is that infiltration trench. And that needs to be sized, that needs to be big enough to handle 740 square feet of impervious area. So we enter that in up here and down here in the bottom table for infiltration trench or dry well, we have 740 square feet. From the table we looked at earlier, we know it needs to be at least 156 cubic feet in volume. It needs to be at least 45 square feet in area because we're going down to a depth of 3.5 feet. And what types of material are we going to use to build it? We're going to use stone, right? We're going to fill it with stone to provide that void space to hold the water. So we submit our simple sketch plan. We submit this worksheet. The final thing that we have to submit is the signed O&M agreement. And you should definitely read this before signing it. But essentially, what it is an agreement between the landowner and the township, where the landowner agrees to operate, inspect, and maintain those BMPs, which are necessary to manage stormwater from the project. The landowner is also required to inform future landowners, right? So this agreement essentially runs with the land. If you sell your house, then the next landowner is going to have to do these same things. They're going to have to agree to operate, inspect, and maintain those BMPs. You're also allowing the township, you're giving them the ability to come onto your property and inspect the BMPs. And if necessary, if you have really neglected to maintain these things, the township is allowed to take action and will be reimbursed for, repairing those things if it gets to that point. And then finally, you're also releasing the township of any liability for your BMPs. Say, for example, I don't know, somebody tripped over your infiltration trench and hurt their leg. That person, that would be your liability, not the township's. And so that's essentially it. That's the simplified approach to stormwater management. And yes, it's very easy for smaller projects, and we hope that everybody will make use of it for their home construction projects. And so with that, I think that's the end of our workshop.
Will, actually, I have a couple questions.
Oh, yes, please.
Okay.
Absolutely.
Can you go back to the sketch of the site?
Absolutely.
So for,
This one.
yes. So we know for the house and the garage, we can't make really those impervious. We can't make them pervious from an impervious surface. But what about the driveway? Are there options that could be actually a pervious driveway rather than an impervious one?
Absolutely. And we actually did a workshop all about that last week on how you can reduce the impervious area on your property. So for example, if we used pervious pavers, right, or some type of porous paving system for the driveway, then this 540 square feet goes away. And now our total impervious area is 400 square feet. We're below the threshold that requires stormwater management planning. I would still suggest that you should, have some rain barrels to manage runoff from the roof of the garage, but you would not technically be required to submit anything to the town for approval if you were under the 500 square foot threshold.
And do you know for changes to existing things, like if for the existing walkway, if that was changed to be a porous surface, could that further reduce the amount of impervious surface on the property?
Yes, it could. So I would suggest, building that into your submission to the township so that, if you're gonna convert this walkway from impervious to pervious, that is reflected, right, in the documents with the township, so you get credit for that reduced impervious area.
Thank you, Will.
You're very welcome.
Oh. One more thing, actually.
Okay.
For the cisterns, you talked about the rain barrels kind of in detail, but not as much the cisterns. Is that something a homeowner could install?
The cistern?
Yes.
Yeah, I think so. Let's take a look at those real quick.
Do those go above ground or underground?
You can put them above or underground. Trying to share my screen. Oh, I'm still sharing. Okay. Yeah, so in this photo here on the bottom, you can see they put it above ground. You can put them below ground as well. You'd have to get ones that are, structural, right? That can resist sort of the pressure from the soil and aren't going to collapse underground or anything. But yes, these things are manufactured for those purposes and are available. Um, Whether you want to install it using a shovel or have somebody come out with an excavator is another question, but they definitely can be used underground. And I guess I'm
So
not
then if
sure
you,
if you're going to put it underground, how do you then use the water? There might have to be some type of submersible pump or hose attachment or something coming up out of the ground, but that's easy enough to do as well.
and I just wanted to share with people that I have rain barrels and I have kind of some screening and stuff, but still I can get some mosquitoes. So I suggest using mosquito dunks, and they keep mosquitoes from breeding.
Nice, thank you.
Thanks again,
You have
Will.
them attached to your downspouts like this, I assume.
I do.
Nice.